Hello, I welcome you all to this another interesting screencast. And the problem reads: if the force F equal to 80 newtons, determine the magnitude and coordinate directional angles of the couple moment. The pipe assembly lies in the XY plane, and in the second case, if the magnitude of the couple moment acting on the pipe assembly is 50 Newton meters, determine the magnitude of the couple forces applied to each range. The pipe assembly lies in the XY plane. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Benam. Right. So we can solve this particular problems by using the scalar or the vector approaches. It's up to you to choose which one is preferable for you. If the problem has not stated which method to use, then you can choose whichever is okay for you. So for me, I'll choose the scalar, and I'll convert the result into a vector, and then I'll find the magnitude of that particular moment vector, and then also find the unit vector along the moment vector, which will give me the directional angles. And in the second case, it will just be the opposite. Moment is already given, so this is just going to be equal to moment. So yes, this is in the second case. Okay, like so, just using Pythagoras. Okay, so this is already given in the second case, so we just equate it and then later on find the force. All right, so let's go ahead. Let's call this one as case 491. Right, so let's find the couple moment. So the resultant couple moment, let me call it as MRC. Okay, is going to be equal to I will just use F for now, the way it is. So let me start with this F, that is negative. What is this component? Moment component along the x-axis. So we'll have this rotation. This rotation is negative. So I will have minus F times the lever arm, which is 300.3, and then this one, this F along the x-axis, it is going to be equal to positive. All right, so this will be plus, this will be plus F by the lever arm, which is 200 plus 300 plus 300, which is 800, right? So 0.8, we close that as the ith component, then plus along the x-axis, along the y-axis, let's start with this one. So we are going to have a positive along the y-axis from that negative couple moment. So this is going to be equal to F by the lever arm, which is 200, so 0.2. And then this other one along the y-axis is going to have a negative. So this will be minus F by lever arm, which is 0.3, jth component. All right, so if we are to simplify this quickly, I wanted it to be like this, and then we are going to feed in the value of F, which is already given. We can told there F is equal to 80 newtons. So now let's work out this. Where is my calculator? So we have minus 3 plus, of course, 8, 6.5 positive. So this is going to be equal to 0.5 Fi. Okay, then the other one is 0.2, of course, minus 3, which is just a negative. So this one is going to be equal to negative 1 Fj. All right. So given that F is equal to 80 newtons, and then we feed this F there, we also feed it there. All right. And once we do so, then we find that our moment vector, this outward moment vector, is just going to be equal to 0.5 by 80. This gives us 40i, and then 80 by 0.1, that is 8, right? So minus 8. Okay, minus 8j. All right. Is everything fine? Everything is fine. Great. So with this information, we can now find the magnitude quickly. The magnitude of this is just going to be equal to 40 squared plus 8 squared. Square root of that just gives us a 40.79 Newton meters. Okay, let me just move this a little bit, maybe somewhere there. All right, Newton meters. And so is also this one, Newton meters. All right, this is also Newton meters. Okay, so now let's find the unit vector along that direction. We call it the unit vector along the couple moment itself is just going to be equal to MRC divided by the magnitude. Okay, and this is equal to 40i divided by 40 divided by 79 minus 8j divided by 40 by 79. Since we want to find the direction, I'll include another component, which is a 0k divided by 40 divided by 79. Right, and therefore cos alpha, which is the angle between the positive x-axis and the moment vector, so this is going to be equal to 40 divided by 40.79, and therefore our alpha is just going to be equal to, I just move it maybe somewhere there so that I'll have space for the others. Okay, so grab your calculator. 40 divided by 40 divided by 79, cos inverse of that, so we get 11.29 degrees. Okay, then cos beta is just going to be equal to minus 8 divided by 40.79. Okay, maybe I should be putting this just underneath like so. Yeah, something like that. All right, and therefore a beta is just going to be equal to, beta is equal to minus 8 divided by 40.79. Cos inverse of that just gives us 101.31 degrees. Okay, And then later on, let me just rub this. Then we have another one which is cos gamma equal to 0 divided by 40.79. Gamma therefore is just going to be equal to 90 degrees. So we are done with the first case. Let's go to the second case. What is the second case? So let's write it down. Second case is 4 dash 92, and here we have been asked to find the magnitude of the couple forces given the resultant couple moment. So we already have the expression. So here we've been given that MR magnitude is equal to 50 newtons. Okay, so we are now being asked to find the couple moment. So we use this equation there. We already found this equation. This equation is equal to 0.5. It's the same equation that we're going to use. Fi minus 0.1 Fj. All right, and writing this as a magnitude, this will just be equal to 0.5 F squared plus minus 0.1 F squared. So let's sum up all that stuff in there. We sum it up, and once we've done so, then we can equate it to 15. So 0.5 squared plus 0.1 squared, what do we get? So we get 0.26 f squared, 0.26 f squared square root is equal to this magnitude, which is equal to 15. Okay, so making f subject to the formula, we can make f subject to the formula. This will give us 50 squared divided by 0.26, then root of that solution. So this gives us a 98.06 newtons. So 50 squared divided by 0.26, then square root of that. All right, of course it will have two solutions, a plus and a minus. Of course we just want the magnitude in this particular case because the directions are already given for a couple, so we pick the positive one. Right, so let's outline the solutions. We have the vector, moment vector for the first case. Okay, and we have this magnitude. All right, and then we have the directions for each one of them, right? Okay, this is still the first case. And then in the second case, the resultant moment was given. We are being asked to find the couple force, which we found is this one here. So this is about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.